gravitation. So, if you remember back when we did a lot of stuff with Newton's laws, we use this little guy a lot. The force of gravity is equal to m times g. Now we know m is the mass and g is this number 9.8 meters per second per second. And a question that a lot of y'all like to ask was, how do we know that? Where does that 9.8 come from? So what we're going to do is we're going to look at where that 9.8 comes from. And it comes from a lot of extensive experimentation and a little thing called Newton's law of universal gravitation. Newton's law of universal gravitation states simply, everything is attracted to everything else. So let's look at, well, we have our dude here. Let's call him Steve. Okay? Steve is attracted to girls. Okay? So we know Steve is attracted to girls. Girls are attracted to Steve. But according to Newton's law of universal gravitation, Steve is also attracted to cows and rocks. And in an interesting twist, according to the law of universal gravitation, cows are attracted to Steve, and so are rocks. And then, of course, everything is also attracted to each other in all of this. So, put simply, everything is attracted to everything else. So, it also gives us this wonderful little formula. Okay, we've got the force of gravity is equal to big G times the mass of object 1 times the mass of object 2 times the distance between the two squared. Now, if it's a distance, why is it an r? Well, we'll look at that a little bit later, but most of the time, when you are using this little r right here, it's going to be the radius of a planet. But first, let's talk about big G here. Big G does not equal 9.8. Okay, little g and big G are two different things. Big G is instead 6.67 times 10 to the negative 11th. So what does that look like in normal numbers? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7. So really small number, really wonky one. We're going to use it mostly in scientific notation because I do not want to type all that into the calculator. So remember, big G is this whole mess, whereas little g is 9.8. So it's very important to remember, big G and little g are not equal. They are two entirely separate things. Big G is the universal gravitational constant, and little g, we'll give it some names later on. Happens to be a couple of interesting things. So let's look at a problem using this formula. So here we have Mr. W. Okay, we'll give him a mass of, I'm feeling skinny today, 100 kilos. I weigh way more than that, but y'all don't need to know that. And this is the good old Dr. Chunky. Dr. Chunky is my rabbit. Chunky has a mass of, let's say 5 kilograms. And because of good, proper social distancing, I am staying at least 6 feet away from my rabbit at all times. Well, let's just say that. So, we have our formula. The force of gravity is equal to big G times, if I can actually write this properly, times m1 times m2 over r squared. So, let's put in our numbers. So that's going to be 6.67 times 10 to the negative 11th. Make sure you put parentheses around that. Times mass number 1, which is going to be our 100 kilograms. Times our mass number 2, which is going to be our 5 kilograms. All that divided by our radius, which is 2. squared. And I'm going to put that in parentheses anyway because, well, it helps me out when we look at the calculators later. So I'm going to go ahead and pull up my calculator here. I'm going to turn it on and clear it out. So we've got 6.67 times, come on, times 10 to the negative 11th times 100 times 5 divided by 2 squared. So let's plug that in. So that gives us 8.3 times 10 to the negative 9. And this is going to be in newtons because it's a force. So let's put that in standard notation. So our force of gravity is 0.1, 2, 3, 4, 5, 6, 7, 8, 8, 3 newtons. So yes, my rabbit and I, according to Newton's law of universal gravitation, are attracted to each other. However, that force is very, very tiny. That's the reason I can't just, pick her up without touching her. Or, all kinds of other stuff like that. So, that is Newton's law of universal gravitation. So where does little g come into all this? Well, little g, what we actually do is we take our normal formula and we sort of slice it in half. Okay? So little g is equal to big G times the mass of some planet divided by the radius of that planet. Okay? So P equals planet. So that means our G is equal to 9.8 is only true on Earth. Okay? Now, this formula right here, okay, this is the formula that you use to find the gravitational field strength. So one of the things that we can call our little g is the gravitational field strength because it represents the strength of the gravitational field that's pulling us down. However, it is also our acceleration due to gravity, which is the reason you normally see it with a meters per second next to it. Now, it's very important here. G changes depending on the planet. Okay? Different planets have different masses. They have different radiuses. So G is going to change depending on the planet. So, okay. Let's look at this one. A nice quick little Earth. Yes, that's Earth. We'll give it a sign. And we've got the moon. Okay. The Earth has a gravitational field strength or an acceleration due to gravity of 9.8 meters per second. The moon, however, has a little g of 1.6 meters per second because the moon is a whole lot tinier than the Earth. So, how do you find the acceleration due to gravity or the gravitational field strength? Well, let's look at the Earth. So, our formula, little g is equal to big G times the mass of the Earth divided by the radius of the Earth squared. So, big G is 6.67 times 10 to the negative 11th. The mass of the Earth is equal to 5.98 times 10 to the 24th. And the radius of the Earth is equal to 6.38 times 10 to the 6th. So that means little g is equal to 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24th divided by 6.38 times 10 to the 6th squared. So let's plug that into our calculator. So go ahead and clear that out. So that gives us 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24th. Okay, wait, divided by 6.38 times 10 to the 6th squared. Gives us a little g of 9.79, which is our wonderful 9.8 meters per second that we are always using. So that go ahead. It concludes the instructional portion. Please stay tuned for a message from me and my rabbit just to help you get through all these wonderful chaotic times.